Hi everyone, in this video we would be designing a very popular game which is Snakes and Ladders. And this question was recently asked into Salesforce. And this is also asked into companies like Uber, Ola, Flipkart, etc. So let's get started. So this is the flow that we would be following in each and every video in our low level design series. The first step is understand the system, and I believe this is one of the important step, because let's assume that I ask you to design snakes and ladder and I also ask you to design sudoku. Then the chances are high that you'd be able to design snakes and ladder, because you have definitely played the snakes and ladder in your life, and the chances of you having played the sudoku is comparatively less. So you might not know about sudoku, right? So if you don't know anything about sudoku, then obviously you can't go to the next step. So that's the reason why we would always try to first understand the particular system briefly. Once we understood that system, we would go to the requirement gatherings part. And what I've done is, in order to simplify this requirement gathering steps, I have categorized that requirement gathering into three categories: extensibility, dynamic, and high traffic. So all the requirements related to extensibility will go into this category. So assume that currently your system has Stripe payment gateway and PayPal payment gateway, but in future you might want to add some other payment gateways as well. So that requirement comes under extensibility, because you might want to add something in the future, but while adding that you don't want to modify the old code. So that requirement will come into extensibility. Similarly, let's say currently you are charging your customer based on time, but in future you might want to charge your customer based on event as well. So this requirement will also go under extensibility category. The second category is dynamic. So all the requirements where user will provide the input will go into this category. For example, let's say we are playing tic-tac-toe. So over there, we can ask the size of the board from the user. We can also ask the number of players from the user. So all those requirements will go under dynamic category. The third is high traffic, or you can say concurrency. So assume that you have a website which allows the user to book a ticket. Now there is one movie going on and it has only one ticket available, I mean one seat available, and two users are simultaneously trying to book the seat. So obviously only one of them should get, isn't it? So that is the time when you have to deal with concurrency. Okay. So all the requirements related to concurrency will go under this category. So once you have written down all the requirements, your next goal is to write down the entities. So you would go through each and every requirements and write the corresponding entities. For example, let's say in this requirement, payment gateways requirement, the entities could be payment interface, Stripe payment gateway, PayPal payment gateway, payment status enum, etc. Okay. So you'd write the entities like this just for yourself. And once you have written down the entities, your next goal would be to connect those entities and try to understand the flow between those entities. Because if you don't even understand the flow, then obviously you won't be able to write the code. So in order to understand the flow, we would be drawing the class diagram. In an interview, you probably might not have access to the whiteboard, or maybe you won't have much time to draw the class diagram. So in that case, you can directly explain the flow. But in the LLD videos that I'm going to make, I will be explaining you the flow through the class diagram. Okay. And in the class diagram, I would be basically using these two kind of relationships. Easier relationship is between class 1 and class 2, when class 1 is a child of class 2. Okay. And has a relationship is between class 1 and class 2, when class 2 is one of the attribute of class 1. Okay. So once we know the flow of our system, we would be easily converting that flow into working code. And these 5 steps basically would help you in your LLD round and in your machine coding round as well. Because the expectation in LLD round is to write down the requirements properly, to write down the entities, and to explain the flow to the interviewer. And in the machine coding round, the expectation is to write down the working code. And in all the LLD videos, we would be covering all these steps. That's why it would be helping you in your LLD and machine coding round. And by the way, I would be explaining this, or I would be embedding this particular explanation in each and every video for the first time visitors. But if you have already seen this particular part, 7 to 8 minute part, then you can skip that in all the other videos. Okay. So now let's begin with our current system. Now let's try to understand what exactly a snakes and ladder game is. So this is a game which is played between multiple players, and each of those players would be starting from position 1 on this board of size 100, and on this board we would be having multiple snakes and ladders like this, and those players would be rolling the dice, and whatever the number comes on the dice, they would move by that much position. And the player who reaches the position 100 wins the game, and there can be multiple winners. Only the last one would be the loser. Okay, so this is all about snakes and ladder game. So now let's try to gather the requirements regarding this system. So I have already classified the requirements into these 3 categories. First is dynamic, second is extensible, and third is high traffic. So what you'll do is you'll start asking the questions to the interviewer. So in the dynamic category, you can ask the questions such as, do we have fixed number of snakes in our game? And same thing with the ladders as well. So in our game, there can be many snakes and many ladders. So let's say the interviewer says that the user should be able to give the input as how many snakes he wants and how many ladders he wants. Now the third point is the size of the board fixed? Let's say the interviewer says that no, I want that to be dynamic. Let's say I want to play on the board of size 36, then I can play on that board. And if I want to play on the board of size 100, then also I can play on that board. So the size of the board should be dynamic. And again, the fourth question is the game played between fixed number of players? No, it can accept any number of players. If I want to play with only one friend, then I can do so. And if I want to play with many friends, then also I can do so. And the final question in this category would be, how many dice should we have? Should we have fixed amount of dice, fixed number of dice, or it should be dynamic? Again, it should be dynamic. That is, if I want to play with only one dice, then also it's okay. And if I want to play with 2 dice, then also it's okay. So I hope now you understood all the questions that you can ask in the dynamic category. Now in the extensible category, the question could be, should I assume that the game would just have snakes and ladders? So obviously the name of this game is snakes and ladders. That's why obviously you would be having snakes and ladders. But let's say the interviewer says no, he wants more obstacles to be supported. So in future, let's say we want to add tornado, portal, etc. Then also we should be able to do so. So in other words, we want to make the game extensible. That is, we can add more and more objects in future if we want to do that without changing the old code. So this point comes under the extensible category. Now the last question is, do we need to build a system where multiple games are running simultaneously? So let's assume that the interviewer says that no, we should only focus on one game, not multiple games. Okay. So we would be only making one game object. But don't worry, I will also briefly explain to you about what we would do if the interviewer says yes in this question. Okay, I will explain that to you while explaining the class diagram. So I hope now the requirements are cleared. After requirements, the next step is to note down the entities. So in order to note down the entities, we have to scan each and every requirements one by one. So the first requirements has this entity called as snakes. The second requirement has this entity called as ladder. Okay. The third requirement has this entity called as board. Fourth requirement has players. Fifth requirement has dice. Right. And this requirement does not have any entity. So I've already noted down the entities over here. So these are the entities as we discussed: snake, ladder, board. And what I've done is I will be further classifying, or I will be further dividing this board into multiple cells. So I will be having one more entity called as cell. Then we discuss about player and dice, and the entire logic of this game would be stored into this game class. So you can say that this is one service class where all the entities would be into action. Okay. And as we have discussed, we would be having ladder and snakes, right? So they both are one type of, you can say, obstacle, right? This is the obstacle which will harm the user, and this is the obstacle which will help the user. Similarly, in future, we can have many more obstacles. So what I've done is I have this obstacle class as well. And this snake and ladder class will be extending that obstacle class. That's why I have added this into the entities. And obviously I will be using the factory design pattern over here because I don't want if else condition into the client class. Okay. Because let's say I want to create snake, then I have to use if else condition. Like if the user has provided input as snake, then I have to create a snake object. Else I have to create ladder object. And in future, obviously this if else condition will keep on growing. So in order to avoid that stuff and centralize that if else condition, I would be using one factory. Okay, so basically we are using factory design pattern, and this is nothing but an enum. So this enum would be having the different obstacle types like snake and ladder. So I hope now you also understood the entities as well. So now what we'll do is we'll try to connect all those entities with the help of class diagram, and we'll try to understand the entire flow. So this is the class diagram of snakes and ladder game. In this class diagram, the main logic of the game lies into this game class. So let's start with the game class itself. So the game class would have these 5 attributes. The first one of which is players. So obviously the game would be played between multiple players. So we have a deck of players. Now I would be explaining you what or why exactly we are using this deck in the code section. Okay. And apart from players, obviously the game would be played on a board. So this game would have the object of board, and this board will have multiple snakes and multiple ladders, right? So in order to initialize the number of snakes and numbers of ladders, I have the variables as well. And here we also have the dice. So the game will also have the dice. And in the constructor, what I will be doing is I'm passing 4 different inputs. One of them would be the total number of dice which we want in our game. The another 2 are for the total number of snakes and total number of ladders which we want in our game. And one of them would be the size of the board. Okay. So once I initialize the board and snakes and ladders and dice, we can finally start the game. So the actual logic of the game would be residing into this function called as start game. Now, as you can see, this game has the board object. So let's see the board class. So the board class would have the size attribute. So let's say we are playing on a board of size 100. So this size would be 100 and side length would be 10, which is square root of 100. Okay. So basically I'm creating a board which is square in structure. Right. And obviously it would be a 2D matrix. So this is the 2D matrix wherein each individual index would be the cell. Okay. So that's the reason why I have one has a relationship between board and a cell. And this board will have couple of functions. The first one is add obstacles. So as you can see, we are going to add the snakes and ladders, right? So for that, I have one function called as add obstacle, which will add that obstacle onto this 2D matrix. And we also have one function called as get new position, wherein the first input is player, the second input is the offset. So for example, a player rolls dice, and on the dice, let's say the total score is 10. So it means that we would be getting the new position of this player. So this player would obviously have the current position. So current position plus this offset would give us the new position. Okay. Now let's see the cell class. So each and every cell will have the position, that is 1, 2, 3 up to let's say 100 if the size of the board is 100. And each and every cell would also have the obstacle. So let's say there is a snake whose head is at cell number 57 and tail is at 17. In other words, I want to add a snake whose head is at 57 and tail is going to be at 17. So what we would do is on the cell number 57, I will create one obstacle like this. Okay. So there would be one obstacle called as snake on the cell number 57 because head is lying on the cell number 57. Whereas on the tail, we won't be having anything. So it would remain as null. So by default, all the cell which are present in this grid would be having obstacle as a null. But when I will be initializing the snake object, it would be initialized onto the head cell where the head of the snake is present. Okay. Similarly, if I want to initialize a ladder, or in other words, if I want to add one obstacle called as ladder, then if that ladder goes from cell number 3 to cell number 95, then on the cell number 3, I will initialize the obstacle called as ladder. Okay. And cell number 95 would remain as null. Okay. I hope now you understood. Right. So each and every cell would have the obstacle, and it has a function called as hasObstacle, which will just check whether this obstacle is null or not. If it is not null, it means that that cell has one obstacle. And it also has one function called as getFinalPosition, which will give the final position where the obstacle will throw the user. So if that obstacle is snake, then obviously that user would be thrown below that cell, else it will be thrown above that cell. So let's see how this function will work. So by the way, this cell is having the obstacle, right? So there is one has a relationship, and I have made one abstract class called as obstacle, wherein all the common attributes of all the obstacles would lie over here. For example, ladder and snake both would have one source and destination. That's why this is present in the abstract obstacle class. Okay. So the source in the ladder would be the bottom of the ladder, whereas the source in the snake would be the head of the snake, right? So when I say move player, so we would just go from source to destination. That's it. So ladder will throw the user on top, whereas snake will throw the user on bottom, right? So this move player function would be called into this get final position. That's the reason why we would get the final position of that user. Okay. And that get final position function would be called into this get new position. We would see this entire thing in the code. Don't worry. So yeah, I think we have covered most of the classes. And one more thing is I am using this factory design pattern. So I have created one factory so that I can directly initialize the objects of different obstacles. So in future, if I also have other obstacles, let's say portal or tornado, I can keep on extending them over here because of this stuff. That is, we have created one abstract class and we can extend this abstract class. And in order to centralize the object creation process, I have created this factory. And we have this dice class, which will have the total number of dice in our game, and a function called as roll, which will roll all the dice and return one output. And the player class would have the name and the position. So this was about the class diagram of the snakes and ladders. And one more thing is, I told you that I will be briefly explaining to you about this point, which is, do we need to build a system where multiple games are running simultaneously? So if at all interviewer says yes, then in that case, we would also have one more class, and let's say the name of that class is game manager. Okay. So this game manager will have a map of game objects. Okay, so since we would be having multiple games which would be played simultaneously, that's the reason why we should be having a map of games, and not just map. Instead, we should be having a concurrent map. because we would be performing some operations on the game, and in the multi-threaded environment there is always a chance where we can face race conditions. And that's the reason why we should play safe. So we can use concurrent map in that case. Okay. So I hope now you have little bit idea about that. But that was out of scope, as over here the interviewer says no. So in the code I won't be including that stuff. Right. So now let's check out the code. So before checking the code, let's first see the output. So in the main class, I am taking several inputs from the user. The first is the size of the board, then the number of snakes which the user wants on the board. Similarly, number of ladders and the total number of players who would be playing the snakes and ladder game, and the total number of dice which we want to use in this game. Okay. And on the basis of this inputs, we would be initializing the game object. And finally, I am taking the names of all the users one by one and adding those user into this game. After that, I am starting the game. Okay. So let's see the output now. So let's say we want to play on a board of, let's say, 36, and the total number of snakes which we want is, let's say, 4, and ladders is 2, number of players is 2, let's say dice is only 1, the name of the player. Okay. So first of all, let's understand the state of this matrix. So initially all the players would be over here. So behind this Kunal, there is also another player which is Shub, but I am only showing one name because obviously otherwise this matrix would not look good. So if both of the players are standing on the same position, only one of them would be shown. And there are 4 snakes, as you can see. So here I have 4 snakes on the board and 2 ladders on the board. And so this ladder is at position number 12, as you can see, 7, 8, 9, 10, 11, 12. So this ladder is at position number 12 and the top of this ladder is at position number 19. So this, if someone lands on the cell number 12, that user would be thrown onto cell number 19, 17, 18, 19. That is over here. Okay. Similar stuff for this ladder. And for the snake, if someone lands on cell number 29, that player would be thrown to cell number 7, which is over here. So I hope now you understood the state of the board. Now both of the player will keep on playing the game. That is, the player 1, which is Shub, will roll the dice, and on the dice is and he got the 4 on the dice. So 1, 2, 3, 4. So after this state, Shub will be present onto this cell, as you can see over here. After that, Kunal will roll the dice and he will be present onto this cell, and they would keep on playing the game. And let me show you. Yeah, if at all any player comes or lands onto the ladder, as you can see, one message would be printed, which is congratulations, Shub moved up through a ladder. And similarly, there would be one message for the snake as well. And finally, one of the player would win the game once that player reaches the cell 36 or whatever the size of the board is. Okay. So this was the output. Now let's check out the code. So these are the classes in our snakes and ladder system. Let's start with the enum. So we have one obstacle type enum, which obviously would have the different types of obstacle in our game. Currently, the game only has snakes and ladder, but in future, if we add any more obstacle, then we can add the type of that obstacle over here. Then we have the obstacle factory, which will help us to create the obstacle. So this is the centralized class where we create the different types of obstacles. Now let's see the different types of obstacles. So this is the abstract obstacle class, and we have two different types of obstacles. So in this obstacle class, we have the source and destination, and one constructor where the first parameter is source, second parameter is destination. Okay. And we have a function called as move player, or you can say throw the player. So what will happen is whenever someone comes on the source cell, that player will be thrown to the destination. So I am just moving that player to the destination. Okay. When someone will land on the source, I will call this function. So this function will move that player to the destination. And we have an abstract function called as get obstacle type, which will be implemented by each of the concrete obstacles. So this is first concrete obstacle, which is ladder, and this is second concrete obstacle. The key thing over here is while creating the obstacle called as snake, here you have to remember that the source would come first and the destination would come second. So in the snake, as we discussed in the UML, the source is the head and the destination is tail. But in the ladder, the source is the bottom and the destination is top. So that's why bottom will come over here, top will come over here. Okay. And the get obstacles type would return the type as ladder, and over here it would return as type of snake. Now let's look at dice and player class and also cell class. So in the dice, as you can see, we have the total number of dice which are present in the game. Along with that, we also have the object, random object, which will be used to randomly generate one number. So when someone calls the roll function, I will roll all the dice which are present in the game, and each and every dice will generate one number from 1 to 6. Okay, and I finally would be adding all of them and return the final output. So this was the dice class. In the player class, we simply have the name of the player and the position of the player. So initially all the player would be present at position 1. In the cell class, each and every cell would have the position like 1, 2, 3, and each and every cell will either have the obstacle. If it has, then obviously one object would be there, or it would be null. So this function would be used to check whether that function, so this function would be used to check whether there is an obstacle on this cell or not. And we also have this get final position. So what we are doing is we are checking whether this cell has an obstacle or not. If it has, then we are just moving that player. So this obstacle will throw that player to the destination. Else the player would remain at this position itself. Now let's see the board class. So the board class has these three attributes. The first one is size of the board. Second one is the length of the board. Side length of the board. And the third one is 2D matrix of cell data type. So in the constructor, I am getting the size as the input, and I am calculating the side length from this size. And accordingly, I am creating one 2D matrix of type cell. Now we have to initialize that 2D matrix, right? Because each and every box of that matrix is nothing but a cell. So for that, I am using this for loop. That is, I'm iterating through the matrix and I'm starting from the last row. Okay. So in the last row, this left to right Boolean variable would be true. So in that case, I am going from 0th column to the last column. So as you might have played the snakes and ladder, in the snakes and ladder also, the first cell, the cell with position 1 is at the bottom row and the 0th column. So that's what we have done over here. And after the last row, I will flip this Boolean variable. So in the second last row, we would go from right to left. And again, we would create the cell for each and every I comma j position, and the position variable, the value would be increased one by one. So this was a constructor. And let's say I give you one position, for example, position number 5. So using that position, I want to get the actual cell. So for that, I have made a couple of functions. The first one is get the actual row of that position and get the actual column of that position. With the help of those, I can just access the cell I comma j. Okay. So in this get row function, what I'm doing is, first of all, this position would be 1 based, right? Like 1, 2, 3 up to 100, or 1, 2, 3 up to the size of the matrix. So I am subtracting that by 1 because row would be 0 based, whereas position is 1 based. So once I have subtracted that by 1, I would divide that by length, side length. So this would give me the row which is from top to bottom. Okay. Because by default, any matrix will have a row from top to bottom. Top row will be considered as 0 by default. But here, since we are playing the snakes and ladder game, so that's the reason why once I get the row, I am subtracting that row from side length minus 1. So this will give me the actual row of that position. Similarly, in order to get the column, we need the information of the row. Once we get the information of the row, I am repeating the same step over here, that is position minus 1. But this time I am doing modulus operation so that I can get the column from 0 to whatever the side length is. So this would give me the column from left to right. Okay. Then I am checking whether the row is even or not. If it is even, then the column would start from right to left. So you might have observed that the topmost row, which is row number 0 in real matrix, it always starts from right to left. Okay. So that's the reason why I am starting from right to left for 0th row. Else I am starting from left to right. So now in this add obstacle function, what we'll do is, this is the obstacle which we want to add, right? So first we'll get the source of that obstacle. Okay, this is the integer value, and using this integer value, I'm getting the actual cell. So we have the source cell and the destination cell. And before adding the obstacle, I'm just checking whether there is any obstacle or not. If there is any obstacle in the source or the destination, then I would not replace that obstacle. I would return false, indicating that I was not successful in adding the obstacle. Else I would return true. Now in the get new position, we would get the new position of this player. Okay. So this is the current position of that player. I will be adding the offset to this current position in order to get the new position. Now, if by chance the new position is greater than the size, meaning if the player rolls the dice and the dice goes outside the size, which is, let's say you are standing on 95 and you roll the dice and it goes outside 100, then obviously that move is not allowed. So I'll just print this message and return your current position. That is, your final position is your current position. You won't be moved. But in other case, I would get the cell of the new position and I would try to get the actual final position, because see, this is when you would roll the dice and move to the new position. But after that, on this new position, you could have the obstacle, right? So this get final position will handle that stuff. We have already seen that. Okay. And if that final position is below the new position, it means that snake has bitten us. Else we have moved up to the ladder. And if nothing happened, then we are just moving from the current position to the new position. So that's what I have printed over here. And finally, we would return the final position of that user. Okay. So now let's see the last class in our system, which is game. So obviously the game would have this many snakes and ladders, and it would have the board. And in the UML, I told you that we would be using deck, but I think there is no need of the deck. Instead, we could use a queue data structure. Okay. We are using queue data structure because each and every player would play one by one. Once the player would play, that player will go back into the queue and stand in the line. And this game also has the dice. So in the constructor, I am taking all the input and initializing the objects. And in order to initialize the, or in order to generate the number of snakes and ladders into the game, I have this function. For this function, let's say I want to add 5 snakes into the game. So I have a while loop, and in that while loop, I am generating two numbers. Up will always generate a number which is greater than down. Okay, so two numbers would be generated. One of them would be higher and one of them would be lower. So using the factory design pattern, I am creating the obstacle, and the type would be the type which is passed over here, that is snakes or ladder. And then I'm just trying to add that obstacle onto the board, and if I was successful in adding that, I'm just decrementing the count. And this is a function just to add the player into the queue data structure. And this is the main function in our game which will actually simulate the game. And in all the game designs, we would have one while loop. Similarly, here also we have the while loop, and this while loop will keep on running until we have only one player left in the game. So over here, we are getting the player from the queue, and that player will roll the dice, and accordingly that player will get the new position. And if that new position is equivalent to the current position, it means that that player was trying to go outside the board. So I'm just offering, or you can say I am just adding that player back into the queue. Okay, else I am setting the new position to the current player. So I'm just moving that current player to the new position. And if that new position is equivalent to the size of the board, then I'm just logging this message. Else I'm just putting that player into the queue again. And I'm just printing the board after every step. So this was the entire code for the snakes and ladder system. If you understood everything, then please like the video and share this with your friends. Thanks for watching.